In this video, we are going to see about winding terminology. The first one we call it as a conductor. Conductor is nothing but an active length of a part of wire which is under the influence of magnetic field, and it is responsible for the induced EMF in an alternator. So these conductors are placed in the armature slats. You can see here a conductor 1 and conductor 2, that is the active length of a wire. Turn. A conductor in one slot, that means slot 1, is connected to a conductor in another slot, that is slot 2. It forms a turn. So here you can notice, to form a turn we need a two conductors. You can see here the multi turns are there, so it's bunch of turns connected together. Coils. Coils is nothing but the number of turns, that means n number of turns are grouped together to form a coil. So in this case it can be a single turn coil and also be a multi-turn coil. So these coils will be placed in the slots. Third one, the fourth one, the coil side. Coil consists of many turns. You can notice here the slot 1 and slot 2. The part of the coil in each slot, we call it as a coil side of the coil. So if you notice here slot 1 and slot 2, the part of wires are the part of coils. Here the coil side is slot 1 consists of coil side 1 and slot 2 consists of coil side 2. The next important thing is pole pitch. The pole pitch is nothing but a center to center distance between two adjacent poles. As you know that in cricket, the pole pitch, the pitch we can note down that is like the distance between two stumps. Similarly here, the distance between two adjacent poles we call it as a pole pitch. So we have to see that for one rotation of the conductor, let us assume that there are two poles. For one rotation of the conductor, two poles are responsible for 360-degree electrical of EMF, right? So if it is a 4-pole, that is responsible for almost 720-degree electrical of EMF, and similarly is going on. So when I am increasing the number of poles, so one pole is responsible for 180-degree of electrical of induced EMF. So here the key point is 180-degree electrical is also called one pole pitch. Suppose an example you can consider here. Two poles are there and 18 slots armature of alternator is there. Then one pole, there are 18 divided by 2, that is 9 slots it should have. So the pole pitch is 9 slots or 180-degree electrical. So here the pole pitch is nothing but the number of slots in the one pole. So that means the 9 slots are responsible for the one pole pitch, or simply we can call it as 180-degree electrical. So this means 9 slots are responsible for producing the phase differences of 180-degree between the EMF induced in the different conductors. So this number of slots per pole is denoted by N. So the pole pitch equal to 180-degree electrical. So that is equal to slot per pole. That means number of slot per pole. Next one we can see it a slot angle. The phase difference contributed by the one slot in electrical degree is called as a slot angle. As a slot per pole contributes 180-degree electrical, which is denoted as a n, right? So the one slot angle equal to 180 degree by n. So you can notice here the conductor 1 and conductor 2 placed in the slot 1 and also the slot 2. So if it is the conductor produces E1 and conductor 2 produces E2, that means EMF of the conductor 2. The difference between that means the angle difference between these EMF, we call it as a slot angle. So just you see here the right side, the winding is there. So you can see here the 8 slots are there. So each, that means the 4 slots will be responsible with the one pole. So totally 8 poles, 8 slots for 2 poles. So the angle you can see here, the angle contributed by one slots will be 180 degree divided by 4. That means nothing but a 45 degree. So that's all about the winding terminology. We'll see in the other series in the next videos. Thank you.